Hello, today I like to present you one of our vibration sensors which are in our product portfolio. That's our contactless fiber optic displacement sensors. So here we see the electronics, and the fiber optic cable is go here to the sensor tip. The light which get emitted here out of the sensor tip get reflected here by the surface of this machine, and the reflected signal went back to the electronics to a photodetector. So, and the light intensity difference will be analyzed. So in this case we can measure. So the electronics is connected here to the Rogaduct T2 unit, which is also able to measure from DC. So if I move now here the sensor tip, so then we can see here, the displacement. So the displacement we can read according to sensor specification in micrometer or millivolt per mil or millivolt per micrometer sensitivity, so which can be computed later on. So for this experiment I like to use and show you the functionality of this contactless displacement and vibration sensor. In some applications it is not possible to put an accelerometer onto the structure because it is somewhere in the end of line test, and it is not possible to connect this kind of accelerometer to the new part because it's not good. In other cases we have the possibility to measure kind of vibration, for example, by using a measurement microphone. However, the structure must generate a signal which is noisy enough so that the microphone can pick up this noise. So if the environmental noise is too noisy, so then this method will not work. The fiber optic displacement sensor does not care about the environmental noise. So means I can have here a machine, let's say a gearbox. The gearbox comes from production or kind of an actuator motor or whatever. And so it is now ready for test. So I will simulate a movement. So we see here now some kind of signal. So now I will change here in the software to full scale range. So to auto range, and we can see here some kind of signal. So now let's assume we want to test the quality in the end of line test of such gearboxes, and it is not possible, as I mentioned, to connect an accelerometer onto the gearbox because it should be new. So in this case we can use for the end of line test the VibeAI software. So VibeAI software is a kind of machine learning program also for persons which don't have deep knowledge about vibration measurements. So let's do now a quality control check. I start up now the software. So it takes a while. So now I have Rogaduct 2, not plug and dark light, but we can make a live measurement. And also for comparison, we take also here the plug and dark light, but we choose now here the RogaDuck 2. So the sampling rate of the plug and dark light is 48 kilohertz, and the sensitivity, let's just say 10 millivolt per some unit. So the unit in this case is not important for the quality control test. We just want to pick up the relevant vibration data if they are in the tolerance corridor or not. So for this reason, the physical units are not important for this test. So the unit, the RogaDuck 2 have 5 volt range input. Now I can adjust, let's say, a bandpass filter of, let's say, 10 Hertz to 8 kilohertz. So now I will make first a reference file recording. So I will make this here a little bit smaller so that you can see something. So now the recording time for the reference file is 81 seconds. So as more data you have, so if you have more data, so then the comparison measurement for the machine learning model will be later better. So, but usually for this initial reference file, longer recording time is better. Later for the test, you can figure it out which kind of test time is the best for the good-bad recognition. So usually if we would have a FFT analysis software, so then we could see here some kind of frequencies. And this is the raw data signal. So the recording is now finished. The reference file is now finished, and now I just make a comparison measurement, and let's see how the detector will, the AI detector will work. So now we can see, so there's not much changed here during this test. Now we can see that this is now a healthy condition. It is of course possible, let's say if the gearbox was a part which have to be tested in the end of line test changed, so then of course you can make a new reference file by this button here, or there's also possible to change the anomaly recognition tolerance corridor. So in this case, authorized user need here a special password, and then it's possible to change here this value, so that this border here, this is a dotted blue line, will be more up or more down. So means will be more tolerant or more intolerant to detect the anomalies. So now I will manipulate the part here. I will make now the gearbox or the item quality-wise worse. So that means I make here a kind of imbalance by this nail. So nothing is changed, and now I just make again a recording. So now the signal looks like this. The raw data signal. So we can see it is now as an anomaly detected. So in case of such kind of anomaly, we can activate here also to the sound card output a signal. So let's say for another system, for PLC system or so that a kind of another action can be released here by this signal. So again, if I remove this here, so now I will make again a measurement. So this is now again a good part. So now it is so la, but the anomaly is still not appeared. So in this case, we can change here this anomaly detection border. Let's say let's make it more tolerant. So now let's compute here again. Aha. This is now more intolerant, so I have to make here this value to 99.89. So now it's healthy. In addition to this, it's possible to set here this values, depends on item which have to be tested, and we can make here also kind of interval recording. So that means, for example, all 10 minutes we can make a test for 30 seconds, so that in case of bearing observation or for predictive maintenance, the system will give you the right one information if the bearing or the item is outside of the tolerance corridor. Important point or topic for this software is that at the end of the day, the operator can use the software more or less intuitive and will get a big success in few minutes or maybe in 1 or 2 hours, and there's no need for him to be a noise vibration harshness engineer or well-educated and deep-educated engineer which understands the spectrum analysis and this kind of things. So this is an important topic that for the operator, there is no need to have a special knowledgement. So this was now the presentation with a contactless fiber optic displacement sensor, and the fiber optic displacement sensor is able to measure under harsh environments. So means we can measure vibrations and distances, for example, in cryogenic areas from almost 2 Kelvin to from minus 270 degrees Celsius up to 800. So there are different probes available with different materials. So it's working under high pressure or in cryogenic area or under extreme high magnetical fields. So especially these sensors can be implemented in mechanics, where, for example, eddy current sensors does not work because of magnetic fields, for example, or like laser vibrometers or triangular displacement sensors simply do not fit into the machine. So this is a big point for this fiber optic displacement sensors. Thank you very much for your attention, and I wish you a pleasant day.